Next property is high electrical conductivity. Metals are good conductors of electricity, while non-metals are poor conductors of electricity. Silver is the best conductor of electricity. Point number 1. Which metal is the best conductor of electricity? Here's something more, that is, some points are given. 1. Materials which allow electric current to pass through them are called good conductors of electricity. This point. Then, graphite is the only non-metal which is a good conductor of electricity. Another point. These two are very important points. Now we are going to do one activity. Activity number 4. Aim to test which material conduct electricity during an electric circuit. Materials required: a copper wire, an aluminum wire, 2 iron nails, square piece of cardboard, and a piece of coal and sulfur. These are non-metals. And let us see what is the activity. Procedure: set an electric circuit as shown in the figure given. That is, you set up a circuit like this using a bulb and a battery and the positive and the negative part of it. And procedure: set an electric circuit as shown in the figure. Does the bulb glow? Why? Now connect the copper wire between the 2 iron nails X and Y. Does the bulb glow? That means if you use a copper wire, of course the bulb will glow. And now remove the copper wire and test with other materials one by one. That means if you observation, the bulb glows when with the copper wire, aluminum wire and the iron nail, but it does not glow with coal and sulfur. That means conclusion: metals are good conductors of electricity, whereas non-metals are poor conductors of electricity. That is, by means of activity number 4, we are trying to prove that if you use a metal wire, the bulb will glow. But if you use any non-metal on the place of these metals, the bulb will not glow. Next property, high thermal conductivity. Metals are good conductors of heat, but non-metals are poor conductors of heat. They are insulators. That means they do not conduct electricity. For that, there is an activity is given known as activity number 5. Aim to show the thermal conductivity of metals. Materials required: a thick copper wire, a wax, a thumb pin, and iron stand with a clamp and a burner. This is the burner, this is the iron stand, and this is a thick copper wire, and on that you are going to place some wax and put a pin stick to that wax. That means wax will hold this place and a pin is placed on the wax. What the experiment is that you are going to heat one end of this rod so that the heat is transmitted and the wax will melt and this pin will drop from the wax. Procedure: take a copper wire at one end of it, put some molten wax and place a thumb pin over it. That means you place a thumb pin. This is the thumb pin. Clamp this end of the copper wire with an iron stand as shown. This is the iron stand. Now, clamp this end, that copper wire, with an iron stand as shown in the figure. Now, place the burner below the free end of the copper wire. Observe for some time. Observation. The wax melts and the thumb pin falls off. That means heat is transmitted through the copper rod. Thereby, from the wax, that wax will melt. This portion also, that wax were there. The wax is melted and this pin will come down. The observation, the wax melts and the thumb pin falls off. Conclusion. The thumb pin and the thumb pin at the other end falls off because copper wire allows the heat to flow its one end to the other. By heating with the burner, the heat is transmitted. Because of the heat, the wax melts. As a result, this thumb pin falls off. The copper wire did not melt on heating because metals really have high melting point. They do not melt easily even after heating for quite a long time. Even if you are heating with this burner, the copper wire will not melt because it can resist even high temperature. The wax and all cannot resist high temperature. That is why wax melts. Therefore, we understand from this activity, metals conduct, that is thermal conductivity. They can pass the heat from one end to another, and they will not melt even if you heat it to a higher temperature.